Welcome to Session 2 of the Current Solar Panel program. In this session, you will be learning about Arduinos, current sensors, and IDEs. To begin, an Arduino board is a simple computer with no operating system. An operating system is the interface you use to interact with computers such as your laptop or smartphone. So, instead of using an operating system, we will be providing machine code from our computers to the Arduino. Machine code is made up of a bunch of series of commands that machines and computers use to run various processes. It is written in binary, or ones or zeros. We can create machine code ourselves by programming in the C++ programming language and using software to convert our code to machine code that the Arduino can understand and use. This software is called an IDE, an Integrated Development Environment. The great thing about an Arduino is that we can connect a multitude of components and sensors to create whatever we want. Here are a few examples of what some people have created using an Arduino. On the left is a biking jacket that automatically gives a turn signal to drivers behind the biker. The top right shows a door lock that will unlock only when a specific knock is given. The bottom shows a robotic arm controlled by an Arduino board. Here is a standard Arduino Uno board. As you can see, there are two ports for power. The power USB is where you can plug the Arduino into your computer and upload the machine code. The barrel jack only provides power. The power out pins can be used to power your circuits. The analog pins connect to sensors that use light or audio. As for the digital pins, they connect to sensors that have binary outputs, either low or high. We will be using these pins to communicate with the Bluetooth module. The SCL and SDA pins help with communicating with sensors that need to take data at specific time intervals. We will use these to communicate with the current sensor. This is the current sensor you will be using in your device. It will read the voltage and current of the solar panel we will be attaching to it. The current sensor works by either measuring the voltage drop at the position where it is placed in the circuit, or by measuring the magnetic field generated by the current running through it. We will be wiring the Arduino board, the solar panel, and a resistor LED combination to the pins indicated above. Now you will begin a small activity that introduces you to coding an Arduino on its respective IDE. You will start by connecting your Arduino to your laptop and running the Arduino IDE. Then go to File, Examples, Basics, and try out the codes named Blink and Fade. Read the description for each and experiment a bit with them. Try to alter the frequency of the flashing of the LEDs on each sketch. Alright, so now I'll be demonstrating activity 2.1. Now in this activity, we want to see if we can get the LED on the Arduino board to blink on and off. Now for this activity, you're going to need an Arduino Uno, a USB connector cable to your laptop, and a laptop. Let's get started. Okay, so for this, all we're going to do is first connect our Arduino board to our laptop using the USB cable. And once we've done that, we want to pull up the Blink example code from the Arduino library, and we're going to hit the upload button. Now what this is going to do is compile our code and send it to the Arduino, and now we can see that the small LED on the board starts to blink on and off every second. Now what we're going to do is go into the code, and on lines 34 and 36, we're going to change these delays from 1000 to 500, and we're going to see the effect that it has on the board. So we're going to change that and hit the upload button again. And now we can see that the LED is blinking twice as fast. Alright, so now we're going to explore the Fade example program. Now, the point of this is to see if we can connect the Arduino to an LED and have that LED fade on and off. Now, for this activity, you're going to need an Arduino and a USB cable, just as before. And you'll also need a breadboard, a red LED, a 470 ohm resistor, and, of course, a couple jumper wires. Let's get started. Okay, so the first part of this activity is building the circuit required. So first what we're going to do is we're going to connect the negative line of our breadboard to be the ground from our Arduino. And ground is marked on the Arduino itself. So we'll go ahead and connect that to the negative side. Then we're going to connect pin 9 of the Arduino to the positive terminal of our breadboard. Then, from here, we're going to connect a resistor from the positive end of the breadboard, and we'll connect an LED in series with that resistor, and then we will complete the circuit by connecting the negative end of the of the LED to ground. Now we won't see anything happen right now, but what we're going to do is pull up the fade example program available in the Arduino library, and we will upload that to our board. Now when we do that, we see the LED fades on and off at a somewhat slow rate. Now if we look in the code, we see that there is a delay on line 39, which tells the program how long to wait between setting the different voltage levels for the LED. Now if we change that 30 milliseconds to just 10, for example, and we re-upload the code, we will see the LED fade on and off much faster. The next activity you will complete is about wiring the current sensor to the Arduino and testing to see if it works properly. To do this, you will wire a circuit as shown on the slide. Alright, so now I'm going to be demonstrating activity 2.2. Now in this activity, we're going to be building a simple current monitoring circuit using the current sensor we just learned about. So for this activity, we're going to need an Arduino and a USB cable, a smaller breadboard. We're going to need a bunch of jumper wires, a 9-volt battery and a 9-volt battery clip, a red LED, a 2.2K ohm resistor, and an Arduino current sensor. Let's get started. Okay, so the first thing we're going to do is connect our current sensor to our breadboard. Now, we're going to wire up a circuit very similar to the circuit in the wiring diagram of construction 1, and that's available on one of the handouts. Now, what we're going to do next is connect the SDA, or system data, and SDL, or system clock line, from the current sensor to the Arduino. That way they can transfer data. So we're going to connect the SCL pin of our current sensor to the SCL pin as indicated on the Arduino. And we'll do the same thing for the SDA pins as well. So now our current sensor and our Arduino can transfer data between each other. The next thing we have to do in order for our current sensor to function properly is we have to give it ground and power voltage. So we're going to connect the 5-volt pin of the Arduino to the VCC pin of the current sensor. And we're going to supply ground by connecting the ground pin of the Arduino to the ground pin of the current sensor. So at this point we have 4 connections made. The next thing we have to do is connect our resistor to the VIN minus pin of our current sensor. And so we'll do so just like this. So now we have our resistor connected to VIN minus, and we're going to connect the other end of the resistor to an LED. And again, making sure we put it in the right direction. Now once we have that, what we want to do is connect the negative side of our LED to the same ground pin of our Arduino. And so we can tie this negative side of the LED to the to the other ground pin of the current sensor. Now in order to test if our current sensor is working properly, we need to supply some voltage to it. and we're going to use the battery and the battery clip to do that. So we're going to take the positive end of the battery and we're going to connect it to the VIN plus input of the current sensor. And then we will take the negative end of the battery and connect it to the negative side of the LED. Now as we can see, the LED turns on. This is because the voltage and the current coming from the battery are traveling through the current sensor, through the resistor, through the LED, and to the ground of the Arduino. So now our circuit is all set, so we can measure the current and the voltage using the current sensor. Now we will complete the last activity for this session, which is simply a continuation of the last one. In this one, you will be connecting the circuit you just assembled to your computer so that you can upload some code to get the current sensor running. First, plug in your Arduino board and run the IDE. Then go to File, Examples, Adafruit INA219, Get Current. Upload the sketch to the board and run it. Press the little magnifying glass in the top right corner to open the serial terminal. You should see voltage and current readings start showing up. Alright, so now we'll quickly demonstrate activity 2.3. Now the point of this activity is to use the circuit from activity 2.2 and actually run code on the Arduino so we can see the current readings from the current sensor. So what we're going to do is go into the Arduino library and look for the Get Current program that comes with the sensor. We're going to upload that to our board. And once it's done uploading, if we open up the serial terminal, which can be opened by pressing the button in the top right of the Arduino IDE, we will see a window with our voltage, current, and power readings. So as we can see, we're reading about 9.5 volts and a current of about 4 milliamps, somewhere around there. Now, if you've wired this incorrectly, you might see some sort of strange readings, such as what we see here, where our voltage is all of a sudden 33 volts and our current is negative, and so we have negative power, which doesn't make sense for this circuit. So we want to make sure, if we see something like that, check all of our connections and make sure that we've wired the circuit correctly. Now you will start the first phase of construction on the solar panel system. Here are the steps you have to complete for this first construction. First, you have to take the circuit you just constructed and place it into our solar panel box. Replace the 200 ohm resistor with a 2.2 kilo ohm resistor. You will then disconnect the 9-volt battery from the circuit and you will place the battery into the battery case. Then, attach the battery case to the side of the box and feed the power cable through the hole in the box. Okay, so now I'm going to demonstrate the first construction of the solar panel device we're going to be building throughout these sessions. So in this first construction, we're going to be taking the completed circuit from activity 2.2, and we're going to be placing it into our solar panel device box. So for this activity, we're going to need the completed circuit from activity 2.2 and 2.3, including the Arduino, the current sensor, all the wiring, and the 9-volt battery. And additionally, we're going to need a plastic case and a 9-volt battery holder. Let's go ahead and build it. Okay, so the first thing we're going to do is disconnect the battery from our current sensor circuit, and we're going to remove the battery clip. Then we're going to take the 9-volt battery holder, and we're going to attach it to the side of our case using some adhesive strips. Now this has already been done. So we're going to open up the 9-volt battery holder and take the battery we just disconnected, and we will connect it in there. So there we go. And then we're going to reconnect this here. So now our battery is in the holder. Now the next thing we're going to do is take the case, or the top off of our case. And we're going to disconnect our Arduino from our computer. And we're going to just take this whole circuit and place it into the box. Just like that. And now the last step is to feed the wire coming out of the battery holder through this hole in the side of the case. And we're going to plug it into the Arduino so we can supply power to the Arduino as necessary. And just to make sure that we've done that right, we can flip this switch to turn this on, and we should see the LEDs on the Arduino light up. That indicates that it's receiving power properly. And so we can turn that back off, and we can put the case on here. And there is the first part of our construction for the solar panel device. This concludes session 2 of the current solar panel program. I leave you with this quote: "I have not failed. I've just found 10,000 ways that won't work."